Something colossal has happened in the outer reaches of the solar system, and almost no one has noticed. A violent collision has been recorded on Neptune, and the first signs of it have emerged in an unusual thermal reading captured by the James Webb Space Telescope. Temperatures have suddenly changed. The planet's atmosphere has become abnormally disturbed, and for the first time in history, the effects of a cosmic impact of such massive proportions have been observed in real time. The data is still being analyzed, but what is known is enough to worry scientists. This collision was not small, it was not predictable, and it may be just the first in a sequence of even more enigmatic events. And what's most disturbing is what comes next, because evidence suggests that Neptune may not have been the only target. It all started with a thermal shift. The James Webb Space Telescope, operating on one of its infrared observation routines, recorded an unusual change in data sent from the region of Neptune. The planet, known for its thermal stability and predictable outer atmospheres, displayed an intense, localized and abrupt heat signature, one that didn't make sense with any previously catalogued weather patterns. For the first few hours, technicians thought it might be a reading error, but the sensors repeated the detection and algorithms ruled out instrumental failure. The anomaly persisted. The rise in temperature in the planet's southern hemisphere drew attention because of the way it broke the expected symmetry of infrared radiation. Comparative maps from recent months revealed that it was not gradual, it was sudden, as if something gigantic had interacted with Neptune, generating an energy spike that could be detected even billions of kilometers away. Inside the astrophysics laboratories, the strangeness turned into tension. The agency responsible for orbital monitoring intensified data collection and called in a multidisciplinary team to reanalyze Webb's parameters. The central question was clear. What could have caused a thermal release of this magnitude on a gas planet in the outer solar system? The unusual behavior raised more than just questions. It created a kind of rupture in the scientific consensus about the predictability of distant celestial bodies. No recent simulations had accounted for such a disturbance, which meant that either the models were incomplete or something new had happened, something the telescope was seeing and no one knew how to interpret. But not all the signs were there. The detailed images revealed an unusual atmospheric shift and a set of clouds moving in counterintuitive ways. And it was at this point that the most feared hypothesis began to be considered aloud, the possibility of a real-time collision. But this hypothesis would not come alone, because the scale of the impact pointed to an object that no one had seen approaching, and its absence raises much more disturbing questions. The confirmation came from a set of converging readings. Intense heat waves appeared in Neptune's southern hemisphere, accompanied by abnormal atmospheric movement, spiraling in patterns never before recorded. Supporting satellites recorded infrared images of a temperature range that simply did not belong to the planet. It was as if a thermal shock had struck a large region of the upper atmosphere, releasing enough energy to temporarily reconfigure the gas planet's dynamic equilibrium. According to preliminary estimates, the collision released an absurd amount of energy, comparable to the simultaneous detonation of millions of thermonuclear bombs. But there was no explosion visible in the traditional light spectrum. What was seen were traces of matter being ejected, clouds of particles being dragged away from the impact zone, and a trail of atmospheric distortion that left meteorological models completely unstable. Even Neptune's characteristic bands underwent changes, as if the planet were trying to reorganize itself after being hit by something that broke its orbital harmony for a few moments. The privilege of witnessing something like this in real time is rare. No previous human mission had recorded the impact of such a massive object on a distant planet with such clarity and precision. The collision was not just an astronomical event, it was a reminder that the universe continues to move with forces we still barely understand, and that stability is always provisional. Now tell me in the comments, what do you think hit Neptune? Was it a natural phenomenon that simply slipped under our radar? Or are we dealing with something that defies our current understanding of physics? Comment below. Your ideas could spark discussions that no one else is having. As researchers try to trace the object's origin based on gravitational disturbances and the collision pattern, an even more disturbing question begins to emerge. Why did this impact happen now? And what might it have triggered beyond what we can observe? The inevitable question that arose after the impact was simple, but without an immediate answer. What exactly hit Neptune? Initial analyses ruled out natural satellites, which had already been mapped, and also rejected the hypothesis that fragments were internal to the planet itself. The object came from outside, but from where? One of the first regions investigated was the Kuiper Belt, a vast region beyond Neptune, filled with icy bodies and remnants from the formation of the solar system. It's where many long-period comets and dwarf planets like Pluto originate. The idea that an object from there could have been ejected by gravitational disturbances isn't far-fetched. But there's a problem. The expected trajectories of bodies in the belt wouldn't normally put them on a direct collision course with Neptune without some kind of outside influence. Another hypothesis has gained traction behind the scenes in the scientific community: the mysterious and still invisible Planet 9. Although not yet confirmed, many believe that there is a massive body hidden on the outskirts of the solar system, capable of affecting the orbit of other objects. If this planet really exists, it could have deflected a smaller body, putting it on a collision course. This would explain the anomalous trajectory. But again, there is a lack of observational data to confirm this origin. And then came the most daring speculation: the possibility that the object did not belong to the solar system at all. An interstellar body, coming from outside, like Oumuamua in 2017. If this is the case, we would be facing a collision between star systems, an extremely rare event, and one with profound implications for modern astrophysics. What's most intriguing is that regardless of its origin, the object was not detected before the impact. It simply appeared in the records after the event. This raises an uncomfortable question. Could there be more bodies like this going unnoticed, waiting for their moment to reveal their presence in the most drastic way possible? The collision didn't end at the moment of impact. In fact, that's where it all began. Instruments captured a sequence of shockwaves ripping through Neptune's dense atmosphere with an intensity never before recorded. The energy released by the shock was so powerful that it temporarily distorted the planet's atmospheric pressure, creating chaotic patterns and spirals of gas that continue to rearrange themselves days after the event. But the effects were not limited to the visible surface. Simulated models indicate that the impact penetrated deep layers of the atmospheric structure, causing unusual thermal variations and an imbalance in the supersonic winds that swirl around the planet. These winds, which can exceed 2,000 km/h, were interrupted in some areas and accelerated in others, suggesting a violent redistribution of internal energy. Neptune's magnetic field, already known to be unstable and tilted, has shown fluctuations that have confused sensors. For the first time, abrupt oscillations have been observed at the magnetic poles, something that could indicate disturbances in the planet's internal dynamo, the mechanism that generates its field. Such changes could have unpredictable consequences, not only for Neptune, but for the electromagnetic environment surrounding its moons. Speaking of which, Triton, the planet's largest moon, has shown a subtle but remarkable response. Small gravitational perturbations have been detected, and there is evidence that the orbits of at least 2 smaller moons have undergone tiny but measurable shifts. Meanwhile, Neptune's rings, faint but dynamic, have shown signs of distortion and scattering, as if the collision had echoed through their structures. And the most disturbing thing is that these effects have not yet ceased. There are ongoing fluctuations, persistent instabilities, as if the planet were trying to absorb the blow or sending a cosmic warning. Events like the Neptune collision may seem too distant to affect us. After all, we're billions of miles away. But this kind of thinking betrays a dangerous illusion that we're isolated in a safe bubble, immune to the chaos of the universe. The truth is that everything in the cosmos is connected by invisible forces that we still only partially understand. A large-scale disturbance on a giant planet can trigger chain reactions that influence the behavior of other celestial bodies. And yes, that includes Earth. This cosmic instability forces us to confront an uncomfortable question. How reliable is the equilibrium of our own solar system? We're not talking about fiction or exaggeration here. We're talking about physics, gravity, radiation, magnetic fields. The universe is not static. It pulsates, reacts, collides, and rearranges itself. And we're in the middle of it all, vulnerable to events we can't predict, even with all our technology. If you've come this far and feel that this type of content really makes you rethink everything you know about the universe, a like isn't just a reaction. It's a sign that you value the search for knowledge, supporting a community that wants to understand what's beyond the obvious. It's thanks to this recognition that videos like this continue to be created, recommended, and reached by those who also want to see beyond the veil of routine. So leave your like on this video now, and perhaps that attention is needed now more than ever. Because when a planet like Neptune suffers an impact that destabilizes its moons, what's to say that something similar, or even stranger, isn't about to happen somewhere else in the solar system, where no one is looking? For decades, the outer planets of the solar system were considered stable, almost static territories, with predictable movements and routine behavior. Because they are far from the Sun and from major internal gravitational disturbances, such as those caused by Jupiter or the asteroid belt, it was believed that giants like Neptune lived in a kind of cosmic silence zone. This paradigm has now collapsed. The collision detected at Neptune is a stark reminder that the universe does not operate according to our expectations. High-energy events continue to occur behind the scenes in deep space, far from human eyes, far from the priority areas of monitoring. This reveals an uncomfortable truth. The solar system, for all its beauty and apparent equilibrium, is just a temporary bubble within a cosmos governed by instability, collisions, and forces that we are still far from fully understanding. If Neptune, a planet with a colossal mass and a powerful gravitational field, can be hit by a massive body, what does that say about the supposed safety of the rest of the system? This impact is not an outlier. It could be part of a larger statistic that we ignore due to technological and conceptual limitations. Perhaps similar collisions have occurred before, without any record. Or worse, perhaps they are becoming more frequent as a reflection of cosmic cycles that we cannot track in real time. And here's the most disconcerting thing. The more sophisticated our observational tools become, the more obvious it becomes that the universe is less stable than we thought. The idea that we live in an isolated, protected system is crumbling. And when a new piece of the cosmic puzzle falls into place, it doesn't bring reassurance. It reveals just how incomplete the picture we think we understand still is. Not everything can be explained by the known laws of physics. When something the size of the object that hit Neptune suddenly appears and causes such an intense impact reaction, without warning, without a traceable trajectory, without a confirmed origin, it is inevitable that bolder theories will emerge. We are not talking about baseless fiction. We are talking about questions that, although uncomfortable, are being raised by scientists, orbital data analysts, and space enthusiasts who have been monitoring these anomalies for years. One of the most intriguing hypotheses is that the object was not entirely natural. Yes, its structure, speed, and trajectory suggest a massive body, but there are anomalies in the record. The lack of prior tracking, the unusual angle of entry, and the electromagnetic interference captured around the moment of impact are all elements that do not fit easily into the classic model of space collisions. This has led part of the community to wonder, what if this collision was provoked? What if whatever hit Neptune was the result of some unknown activity, perhaps even external to our solar system? Another more controversial but no less discussed line of thought points to artificial technologies of as yet unidentified origin. The existence of interstellar objects like Oumuamua has already called into question the exclusivity of natural bodies traveling through the cosmos. Now, with this impact, the question grows: what if we are witnessing the action of something beyond the current understanding of astrophysics? It is in these gaps between confirmed data and unexplained phenomena that the greatest leaps in science emerge. The discomfort of not knowing is precisely the driving force behind the most relevant discoveries, and when even official channels remain completely silent, it is only natural that the questions become louder. This is something that few people know. Share it now and bring more people into this conversation. Who knows, maybe the answers will come from those who dare to think differently. Now, with all these hypotheses in the air, there is an even more disconcerting question that the most recent data is beginning to raise, and that could change our view of the entire dynamics of the solar system. For decades, our view of the universe has been limited. Telescopes like Hubble have opened important doors. But what James Webb is doing now completely redefines the way we see the cosmos. This is not just another scientific instrument. It is a technological leap forward, capable of revealing what was previously simply impossible to detect. The impact on Neptune was only observed because of the incredible sensitivity of James Webb's infrared sensors, which captured minute changes in the planet's thermal radiation, something that any other current equipment would be unable to detect. We're talking about a telescope that can look back into the universe's past. Literally. The light it captures comes from billions of years ago. And that's not a metaphor. The further away Webb looks, the further back in time it's looking. But the most surprising thing about it isn't just its range, it's its precision. It can detect gravitational distortions, analyze the atmospheres of exoplanets, and now witness cosmic events in real time with unprecedented detail. This collision with Neptune, which would probably have gone unnoticed in the past, has become a landmark event, not only because of the event itself, but because it represents the beginning of a new era of space observation. The James Webb is allowing humanity to see what was previously invisible. And that's not just a symbolic statement. Faint celestial bodies, radiation anomalies, gravitational vibrations, all of these are now accessible. And that changes everything. For the first time, we have a chance to see the chaos and complexity of the universe in clearer terms. We are beginning to understand that space is not a place of silence and absolute equilibrium. It is a dynamic, active, and often unpredictable field. And now that the eyes of science are finally open, the only question left is, what else is hidden around us, waiting to be revealed? There's a detail that few have noticed in James Webb's latest thermal recordings, and it points to something even more intriguing than the collision itself. The collision was just the beginning. When something like this happens on Neptune, so far from Earth, the truth hits home with a brutal force. There are forces at work in the universe that we don't yet understand. For years, we were led to believe that the outer planets lived in absolute equilibrium, static, dormant, unreachable. But now we know that chaos doesn't respect distances. It just waits for the right moment to reveal itself. The universe is not silent. It is screaming. And for the first time, we have the technology to hear it. The impact that shook Neptune has been detected. But how many other signals are going unnoticed right now? How many echoes of the unknown are bouncing around in the void, waiting for watchful eyes to find them? We may have just witnessed the surface of something much deeper. What if this collision is the clearest warning yet that the solar system is not as stable as we thought? This is where curiosity becomes essential. Because with each discovery, a new question arises. And that is exactly the purpose of this channel, to take you beyond the surface, revealing the phenomena that are silently transforming everything we believe we know. To continue receiving revelations like this, activate the bell and subscribe. Now, it's not just about being in the know, it's about being part of a community that thinks beyond, that seeks to understand what the common eye ignores. Here, each video opens a new crack in the known reality, and you won't want to miss what's coming. And now, with everything we've just seen, perhaps the